Never forget to stay hydrated. And this is why I have my glass of water right here. Alright, hello everyone. Today we're going to be doing Advent of Code Day 5. And Advent of Code is basically a challenge where every day this person releases 2 puzzles, and every day until Christmas. So, counting down the days, right? So, we're going to be doing Day 5. I'm going to be solving the problems and then explaining them. And today, we actually have a special thing in the video, special mechanism that I guess you're about to see. So, we're going to read the problem. Alright. Day 5, binary boarding. You board your plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all of the flight attendants are busy with a flood of people that suddenly made it through passport control. You write a quick program to use your phone's camera to scan all of the nearby boarding passes. Perhaps you can find your seat through process of elimination. Instead of zones or groups, this airline uses binary space partitioning to seat people. A seat might be specified like FB, FBB, FF, LR, where F means front, B means back, L means left, and R means right. The first 7 characters will either be F or B. These specify exactly one of the 128 rows on the plane. Each letter tells you which half of a region a given seat is in. Start with a whole list of rows. The first letter indicates whether the seat is in the front or at the back. The next letter indicates the half of the region that seat is in, and so on until you're left with exactly 1 row. Okay, so there's they give an example. Okay, the last 3 characters will be either L or R. These specify exactly one of the 8 columns of the seats on the plane, numbered 0 through 7. The same process as above proceeds again, this time only with 3 steps. L means to keep the lower half, while R means to keep the upper half. Okay. Fabulous. So then they just give some examples. As a sanity check, look through your list of boarding passes. What is the highest seat ID on a boarding pass? Okay, so we got a puzzle input. Fantastic. So I'm actually going to be using dark mode. I don't usually use dark mode, and I know a lot of you are going to hate me for that. Just like that, but I just prefer to use light mode. It's like higher contrast, and I don't know, that just works better for my eyes. So yeah, I'm gonna actually be using dark mode today because while I'm coding, there's gonna be a 5-second montage of me coding, and we can't have like switching between light mode and dark mode because that's gonna be like really, it's gonna be like really flickery, and that's not gonna be very good. So yeah, I'm just gonna be coding in a dark theme editor. So cue the 5-second montage. Alright, so we have arrived at our answer, and it is 858. So you saw me fiddling around a bit there, with a bit of different solutions, and I'll explain that later. Okay, so we got the right answer. So it's time to explain how I actually got my answer, and this is actually going to take a bit longer, probably, than maybe the previous ones, but it won't be that hard. So let's get to explaining. So the idea here is that if you have let's just consider the row first. So we're trying to find a row from 0 to 127 inclusive. So we loop through each of the 7 first characters because those specify the row, right? The first character specifies the front or the back, right? So if it's front, that means you're in the first 64 seats. And if it's F, you're in the first 64 seats. And if it's B, you're in the back 64 seats. So if it's a B, that's basically like adding 64 to your row number. And if it's F, that means you start at 0, right? And then for the next character, if it's F, you're adding nothing again. If it's B, you're adding 32 because this character, the second character, is deciding the lower or upper half, and that's a difference of 32. It might be better if I drew this out, but this is basically just like binary. You're considering like the value of each of these characters. So the first one is worth 64. If it's B, you add 64. The second one is worth 32. If it's B, you add 32. If it's F, you just add nothing, and then you repeat for the other ones. So it goes. The next one is 16, and then the next one is 8. So because you're basically splitting these sections in half. And each time you split in half, if it's F or B, that's a difference of half that amount. So taking a look at the code might be a bit more clear. So for the first 7 characters, that determines the row. If that character is a B, then you want to add this power of 2. So starting out, I is 0 for the first character, and the first character is worth 64. There's a difference of 64 depending on if it's F or B, like if the other characters are the same. So if I is 0, this is worth 64, so you want to do 1 to 64. And then as I increases, the power of 2 decreases. So that's why we invert it over here. And this is only if the character is a B. If the character is an F, then we don't add anything, because B makes it go further back, you know? And for the columns, we basically just do the same thing, except there's only 3 characters now. And we want an R instead of a B to increase our column number. At the end, it says our ID is going to be our row times 8 plus the column, so that's exactly what we do. And we want to find the highest seat ID on the boarding plane. Okay, fabulous. Now we're going to move on to part 2. Ding! The fasten seatbelt signs have turned on. Time to find your seat. It's a completely full flight, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 and -1 from yours will be in your list. What is the ID of your seat? Okay. Wait, I need to think about this. Some of the seats at the very front and back of the plane don't exist. Okay. Oh, okay. I see. So, I see. Okay. So, basically, we just need to get a list of all the IDs, and then we just find the one that's missing. And then we need to find the bounds. So, some number of IDs. Okay, you know what? Why don't we just cue the montage first? Okay, so we have an answer. Our answer is 557. That is the right answer. Dang. Okay, so this problem was probably a bit confusing for some of you. It was confusing me, as you could see. But basically, it's pretty similar to the first one. But I'm just gonna explain. So the problem statement is probably the most confusing part. There are no. Basically, you're given all the IDs. Well, you can figure out all the IDs from the boarding passes. So in the plane, there must be a min ID and a max ID, right? Because the number of seats, the seats in front of the min ID, the seats in front of the min ID seats are not on the plane, and the seats behind the max ID plane are not on the plane. So we can get the bounds by taking the minimum and maximum value, and that's what these 2 lines of code do. They determine the range that possible seats can be in. And then basically, after we sort the IDs of the seats, we want to find there's some seat in there that's missing. So in between the min and max seats, there's one seat that is not occupied, or it's not on boarding pass, right? So that doesn't have a boarding pass. So we want to find that seat. So in between the minimum and the max. Oh wait, actually we never used that. Okay, but I guess this is just for explanation purposes. But after we sort it, so for example, if there were 8 seats on the plane, we would have maybe 2, 3, 4, 5, 6, 7, except one of them would be missing. So maybe it'd be 2, 3, 5, 6, 7. We want to find the one that's missing by finding the one that doesn't have the seat in front of it. So in our example, 2, 3, 5, 6, 7. 3, after we look at 3, we would see that there's no 4. So then we would know that 4 is the missing seat. And basically we just loop through all the IDs, and for a given ID, if the immediate next ID is not equal to our ID plus 1, so in our example, like 2, 3, 5, 6, 7. We would go to 3. We would look at the one ahead. We would see 5, and then we would see that 4 is missing. So we would know that 4 is the answer. So that might have been a bit confusing, but hopefully that made sense. Yeah. Okay, cool. Hopefully that made sense. I'm going to be pushing this to GitHub as well. If you have any feedback for me, please leave it in the comments. And yeah, I'm going to also link to the puzzle in the description, as well as the playlist for all previous solutions and hopefully all future solutions, if I continue to do this. So yeah, I guess thanks for watching, and I will see you tomorrow. Goodbye.